Hi, my name is Mark Willis. On behalf of the National Weather Service's National Wave Team, I'm excited to present an experiment we're conducting to add wave detail to our marine forecast. Before we go into the specifics of the experimental coastal waters forecast you'll be seeing, it's important to highlight that waves have three fundamental characteristics. All waves have a height, a period, and a direction. Wave height and direction are fairly basic. The height is how tall the wave is from trough to crest, and the direction indicates where the waves are coming from, not the direction they are headed towards. Wave period is a little more complicated, but arguably the most important of all three of the fundamental characteristics of waves. The simple definition of wave period is how long it takes for two successive wave crests or troughs to pass a fixed point in the ocean, such as a buoy. Meanwhile, wave length is the distance between two successive crests or troughs. Wave period is also related to several other parameters such as wave speed, how energetic it is, and how deep the wave extends into the ocean. Wave period also influences the size of the breaking waves we might see at a beach or near an inlet. One reason the National Weather Service is adding wave detail to our marine forecasts is because it is incredibly common to have multiple coexisting wave systems passing through a particular point or region in the ocean. All of these different wave groups can have different heights, different periods, and different directions, and thus have very different impacts on vessel behavior and breaking wave characteristics in the surf zone. If we don't provide that information, we may not be providing mariners and beachgoers the information they need to decide whether it's safe to venture out on a particular vessel or not. Presently, most of the National Weather Service offices on the east and Gulf Coast only provide significant wave height, which is the average of the highest 1/3 of waves at any location. Significant wave height is extremely valuable, but it does not tell us when multiple wave groups are passing through each other at a particular location, and it also doesn't tell us vital fundamental things like wave period and wave direction. Meanwhile, most of the West Coast and Hawaii provide wind wave and swell information, but they do not include all of that fundamental height, period, and direction information for each wave system. This animation shown on your screen now is just an illustration of what is fairly common across the ocean. Imagine the arrows on this graphic are different wave groups that are impacting this sailboat at the same time. The various wave groups impacting this sailboat are likely producing pretty rough conditions, as the boat has waves coming at it from all different directions and perhaps different heights and different periods as well. Our project strives to break this information down so mariners know exactly what to expect before they venture out in the water. For example, a frequent occurrence on the East Coast in the fall is to have a short or mid-period wave from the north or northeast behind a cold front or associated with a nor'easter, while at the same time having a longer period wave system from the southeast or south associated with a distant tropical system such as a hurricane. Meanwhile, off the west coast, it's common to have a short period wave system from the northwest or north associated with the subtropical high pressure over the North Pacific, along with longer period wave systems from the west, northwest, and or south associated with distant storm activity. The same can be said for Hawaii, which has exposure to storms from all different directions that can lead to a variety of mid to longer period waves that coincide with the frequent short period waves associated with local east and northeast trade winds. We've learned over the years that different mariners and users care about very different things, so we want to provide the details you need so you know exactly what you're getting into before you venture out onto the ocean. For example, smaller boats, especially those with flat bottoms, may want to know about short period wave systems because they're quite rough, steep, and choppy, and thus may pose a capsizing hazard. Meanwhile, other customers may be more interested in longer period waves because they generate shoaling hazards near the coast and around inlets. Some mariners may care about all the waves present at any given time at any given location. The point is, when you only provide significant wave height, it can be misleading given that there may be multiple wave systems with various heights, periods, and directions that are occurring simultaneously. As a result, our experiment will provide you with the current operational version of the coastal waters forecast, and for comparison, allow you to view it side by side with the proposed version that adds wave detail. In the first example shown here, you can see the existing forecast on the East Coast that provides significant wave height labeled as Cs in red, with the proposed version of the marine forecast in green, which will continue to show the significant wave height and then be followed by the wave detail that makes up that significant wave height. And as shown here, that's a 5-foot northeast wave at 5 seconds and a 4-foot southeast wave at 15 seconds, which is a fairly common occurrence in the fall. In this next example, you can see an existing forecast from the West Coast that provides a wind wave and swell forecast in red. The proposed version keeps all that vital information and adds a period and direction to short period waves, which are currently labeled as wind waves, and it also removes the wind wave and swell terminology so we can focus on that ever so important height, period, and direction of the individual wave systems. We've also added the valuable significant wave height by popular demand, which allows us to quickly compare the forecast to what is being observed on our local buoy network. Thank you so much for your time, and we hope you see the value in the wave detail experiment. Have a safe and prosperous boating season.